All right. Hello, everyone. I'm Vaibhav. I work on BAML, and this is AI that works. And right here, I have Dexter.
What's up? I'm Dex. I work on a company called Human Layer. And this is AI that works. I know you already said that, but I said it again because it's
And
fun
it
to
sounded
say.
a lot better.
What do
So,
we do? Vibe, what do we do on the AI that works show? Why don't you fill
um,
these fine people in?
yes, the whole goal of this content is, as per usual, to give everyone pieces of work, pieces of AI pipelines that actually work and function beyond just demo code, and go in depth and talk about technical stuff. Today's topic is a topic that has been requested many, many times, but I think it was related to what we had talked about before with interruptible agents, and that inspired this to come up again. And that topic is voice agents. How do we build voice agents? We're gonna try and go ahead and start off with general whiteboarding, as per usual. Then we'll show off some code. But this episode, I think, is going to be one of the most interactive ones. So if you guys have ever worked on voice agents, have thoughts about them, have questions, keep the questions coming in the chat. We will do our best to make sure that we answer them in as expedient of a manner as possible. If you feel like we missed them, just send a gesture our way using some of the emojis or raise hand feature. We'll see them for sure. But with that, I'll let Dexter share his screen, and then we'll go straight into whiteboarding.
Cool.
Cool.
It's a whiteboard. Um, cool. So, Vibe, you have the link to this, right?
Yes, I'm pulling it up right now as we speak. I just don't
Okay,
have
cool.
an extra monitor right now, so I figured it's much better for you sharing. Cool.
Um, cool.
The
I'm
question before you or while you're doing your whiteboarding, why would we build our own interruptible agents and not use one of the platforms that provide agents, voice agents out of the box?
well, I think that's a great question. Like, why not use a voice agent out of a box? And I think it's the same reason that you probably don't want to build a voice agent. You don't want to build a chatbot out of the box. While you can use all these platforms to go do things, I think it's good to be able to choose to use a platform, but you probably want to know what the platform is doing under the hood. And then if you find that what the platform is doing is good for your needs, go use it. It's actually great. But oftentimes, I think the first step is often just knowing what's actually going on under the hood. And that's what the conversation today is about. The trade-off is really product specific and use case specific. So we can talk more about any specific idea after we discuss how a voice agent works under the hood. Thanks for asking.
Yeah, for what it's worth, they're like way harder to build than chatbots because there's a million more things going on and the technology improves so quickly. I spent like 6 months working on voice agents, and like if you build on one specific platform, like you're gonna get cooked. It's you're just gonna have a bad time. They all
Because you're going
have
to be
different
waiting.
weaknesses. Yeah.
You're just
Yeah.
waiting for them to catch up with whatever the new
hmm
tech or the new model is.
Yeah, like speech in, speech out models are like not good enough. They're just not consistent at like structure generation and tool calling. And what you end up having to do is build a pipeline where you have like a bunch of different components, including an LLM, speech to text to speech, like ideally a semantic VAD, an EOU machine learning model, and it's a ton of other stuff. And like you want to be able to use the best for each one of those in terms of like latency and consistency and pronunciation for your use cases. And like no single platform is going to give you the best option for all of those. So you really need to like build a pipeline that works for yourself.
Yeah. And
Sounds
this
like
is all
Sounds
of
like
it.
Kyle is volunteering to lead the follow-up episode on super advanced voice agents.
And just to be really clear on this, the caveat here is assuming that a voice agent is critical to your business. If it's not critical to your business, do whatever you want. But if it is actually critical to your business, like everything else on AI that works, understand how it works, and then you can do whatever you want with it. It's not that hard. So the benefit a platform gives you is really just time to market. And if time to market comes at the cost of accuracy, for some use case, that's okay. But for almost everything else, it's just not worth it. Cool. Let's draw out the first part. Oh, that is not what I meant to do. Voice agents are weird. And I think the first weirdest thing about them is that they operate on a timeline in a way that very, very few other systems do. Because sadly, voice conversations are just monotonically continuing onwards, and they're just going to move forward in time, regardless of what your agent is doing. And the reason that this ends up happening is because if your user talks to you at this, what is going on? How do I change that? Um, That is not a thing that I'll ever use. If your user talks to you at this moment in time, and your voice agent later responds at this moment in time, and your voice agent later responds at this moment in time, but while you're generating something, the user generated a new message at some time in this time period, it's just not going to feel pretty for the user. The other sad part about voice agents is actually there's no such thing as moments in time. I actually lied over here. All of these are time periods. Your user is going to be talking for some duration. Your voice agent is going to be responding for some duration. Your user is going to be interrupting for some duration. And building in these control flows is why the episode for interrupts is almost definitely the one that drove this to a decision. Because in voice agents, interrupts are not optional to design around. They are the primary design mechanism you have to think about at every single step of the way. And go ahead, Dex.
Just to make that like a little more concrete, like your agent would start talking and then your user would start talking, and you'd have to detect the start of this, which would like create an early end to this, and then kind of restart another agent response. And so it's like you're like resteering in real time, and it's not just like a singular stream of events. You kind of have to monitor multiple streams in parallel, basically.
Exactly. And what you do really depends. Maybe you want your agent to finish a response and then pass this into the user and then respond again. Maybe you want your agent to immediately stop, address the user's concern, and then continue onwards. But all of these things are just caveats that are very important design decisions that have to be made, because everything here is time chunks and spans of time. And that, I think, makes the problem infinitely harder than a simple chatbot. The other problem is when you do a voice agent, UX is not your friend. The only UX modality that most voice agents have are purely voice. You don't have a screen, you don't have UXs where you can pause input, where you can like gray out text boxes, you have no loading spinners, you have only voice. So I think in today's conversation, what the most important thing to
Hallo.
talk about is how are we going
Jetzt
to
habe
get
ich schon nett gesprochen. Ich setze für, dass das wir gerade so einen Ausfall gehabt haben, oder?
a co-host, mute Martin. So I think today what we really want to talk about is a couple of things. One, how are we going to take the concepts that we learned from the interrupt video and apply them to voice agents? And then two, how can we design UX so that it doesn't feel as bad as just waiting for a voice agent to go and respond with? And I think those two techniques will help us hopefully build really, really amazing voice agents along the way. And these won't be the only two techniques, but I think these are the two that we can focus today's conversation on. The first one, Kyle already alluded to. Kyle's already said this. Speech-to-speech models are just not good. You can't do this yet.
You can't context engineer them at all because they're receiving like audio tokens that they separate into like semantics and stuff, and then they generate tokens for audio. Like you have no ability to like take a tool call and transform, like you can't own the input as well because it's a lot more of a black box in terms of how the model actually like sees the prompt.
Exactly. So don't do this. It's not worth your time. I think I would wait for someone else to build this out first and prove that it works before you spend your time doing this, is the way I would describe this. What I would do instead is we still want to have speech in, speech out, but we're just going to break down this process and simply make these much, much smaller. And I'm doing these, by the way, by size based on the size of the models usually. This is a text to speech.
Speech to text?
Sorry.
Yeah, it's over there. Okay.
Speech to speech models also tend to be like way more expensive based on like working with GPT-4o's real-time model or Gemini's real-time model, like they tend to be an order of magnitude more expensive than the corresponding text model. And part of that's because you need like a stateful bidirectional communication, which usually looks like WebRTC or WebSockets and stuff, which is harder to scale. It's stateful. It's harder to recover from if something breaks or the user has a disconnection. And so like there's all kinds of really good reasons to not do it. Like you could do a whole episode of just why to not use these things yet because they're just not good enough. And
Exactly. So don't do it. You will save yourself a lot of headache. Now, that said, if we do use speech to text with an LLM and then a text to speech at the end, we'll run into other problems that are very tricky, which is how the heck do we make this thing actually good? Because if an LLM is sending data out, how do you actually stream audio out? Well, there's a lot
Question.
of, go ahead.
I would be really curious. You keep saying good, and you finish this point, but I'd love to kind of just enumerate 3 or 4 things that make a voice agent good. Like what are our kind of capabilities that we're after here?
That's actually that's a great call out, Dexter. I think when I use a voice agent, the number one thing that I look for is really this is concreteness. I'll use very concrete examples first, which is latency. I just wanted to say stuff to me correctly. Like I want to say stuff to me fast, so I'm not waiting for it all the time. I want
Right,
it
the
to be accurate.
pause when I say something and then there's a 2-second pause because the language model is thinking. That sucks.
Yeah, exactly. Like that's okay on a loading spinner in a chat app. It's not okay when I'm talking to something.
Because it
It
doesn't feel human.
it's not it feels worse than like the control flow that I used to use with like a phone pad, because at least there I can just press 9 and 8 and move to the menu section I want. Here I have to like wait forever, and that is like if you've ever used like a phone book that says press 1 for English, press 2 for Spanish, and you have to listen to the whole thing before you can press 1, that is the most frustrating experience ever. And this is like pre-voice models, so like now it's just even longer because I need the
Okay, cool.
model.
So there's also like interruptibility of just like I don't want to hear what the rest of you have to say. Just take me to the next step.
And that's kind of, but I bundle all that with latency because interruptibility is like what I said, but really what I want is I just want latency to be real. I want it to feel fast in how I communicate, and I personally value that much more than accuracy. But accuracy comes as a close second.
Which is
And
like
then
it's correct and high quality.
exactly, it just has to be correct and high quality. And lastly, honestly, it's just vibes. Like when you use a voice model, I feel like you can just tell that something is really good. If you've ever used one of those ones that have gone viral online, like the ones where there's this one that went viral a while ago where you would text it and it would basically you'd give it access to everything and it would try and just like troll you when you spoke to it. I can't remember the name of it, but my cousin had showed me, and when I saw it, I was like, "This is kind of dumb." But then when I actually used it, it actually felt really good because it spoke to me like a friend would be speaking to me if I was 20. It had perfect Gen Z slang, and I don't mean like the ChatGPT Gen Z where it adds the emoji all the time, but I mean genuinely spoke like friends in his phone book would speak. And it did this by copying his email, copying his Slack, copying his Twitter, and just getting full access to it. So it just felt very, very human. It felt like it had a real personality to itself. And I think that's the last part of what makes a great voice agent, something with a real personality.
Cool.
one of the main things that contributes to vibes too is like how conversational the agent is. And um, that's not just like people will think that that's just like how good the text to speech is and how emotive and expressive it is. But like one of I think the biggest determinants of like the vibes of it, and like this will make a really good agent awful or like a decent one like really good, is how well it actually handles interruptions.
Yeah.
And this is like one of the reasons you shouldn't use a platform, is like a lot of speech to text like streaming transcription models, like deepgram, will tell you, hey, the user finished talking now, but they're not great at it and it's really unreliable. Even if your agent or your voice activity detection and end of utterance detection are like 95% accurate, that's still a really, really, really bad user experience. And the best voice agents are using custom machine learning models Like OpenAI recently introduced semantic voice activity detection. That's not just like looking at the audio waveform to figure out, is this a person talking or is this a waveform for like a door slamming or something. And then for end of utterance, like you want to figure out not just, oh, did the user stop talking? Because you can look at the waveform to do that, but the user might have just paused for a second or two while they're thinking or while they're like looking up information. Like a lot of end of utterance models that aren't like really good semantic models will just say, oh, the user stopped talking for half a second, start generating the LLM response. And that results in the LLM interrupting the person in the middle of a thought. And so there's really good models out there now, like LiveKit has some good off-the-shelf ones that you can use for end of utterance that actually like semantically looks at, not just, oh, did the audio stop, but is this actually the end of an utterance, or is this in the middle of like some semantic expression, like a thought? Because that makes the difference between like the model thinking that it got interrupted when it's just background noise. And so it will stop talking in the middle of saying something, and the user gets frustrated really quickly. And also, like the difference between it interrupting you all the time because you talk slowly or because you pause sometimes or you have to go look something up and it gets in a loop and like it interrupts you and you weren't done talking, so you like
Yep.
start talking before and it just gets into a really bad cycle. So like those are also really key parts of the vibes thing. Is just like, does it actually really 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 like grok like the conversation and not just like, oh, audio started,
Exactly.
audio stopped.
Exactly.
What was it, the model that you recommended, Kyle? Can you drop it in the chat?
The live
Um, yeah, LiveKit's a platform. They have some good models. There's really good models for it on Hugging Face. Like I don't have a specific recommendation about them. I've used a couple of them.
All right, we'll get
But-
some links and put them in the show notes afterwards so you can check them out on GitHub. Perfect.
But
All right, bye, Bob. Back to what we're building.
yeah, this goes back to what I think makes a voice agent good, but everyone has their own opinion. So once you can define your own opinion, you can tweak rubrics accordingly. But now let's go back to what it actually takes to make a pipeline. So the first thing is we agree that we're not going to go use a speech-to-speech model. We're going to use speech-to-text, LLM, and text-to-speech. Now the problem with this is naturally a highly latent pipeline. No matter what you do, you're going to add latency here. So what can we do to make this better? Well, there's a couple of things. Well, the first thing that we can do, and I don't know if, I'm not actually sure if Cursor does this for sure, but I wouldn't actually be surprised if they don't do this, which is you can actually add in gaps when you're running stuff. So the first hack to latency is actually to pretend like you have no latency. If any of you know what Instagram did when they first got famous with their image uploads, as soon as you selected the image, they started uploading it to their backend. And then if you chose not to actually publish it, they would just discard it from their backend and throw it away. But if you did publish it, they would actually have it and they'd be like, people would be like, how the heck is Instagram uploading my images so fast? The magic was they just started uploading data much, much faster. The trick to having better latency is literally to start speaking before the LM starts generating tokens. You will have better response times no matter what you do. So for example, that there's some common phrases that are pretty good. Sure, let me take a look, or such variants of this. You could tell the LLM that you are going to start, in your prompts, you could indicate that you're going to start with some phrase, and the phrase can be a variable of some kind that you swap out between like 70 or 100 hard-coded phrases that you can just code gen in the beginning. And you just have the model go say this in a pre-recorded voice ahead of time. And once this is done, you then tack on the rest of your text with an LLM.
Okay, so in this case, your context window might look like you have like your user message of like, hey, the example I'm doing is like a voice assistant for like a doggy daycare. So it's like, hey, I want to board my dog. And then you would speak this. And then you would send to the LLM, sure, let me take a look. So we'll call our assistant messages and user messages. and then you would send this to the LLM and say, what's the next message? And then the
Exactly.
LLM would say, like, I'd be happy to, it looks like we have availability or whatever it is.
Exactly.
And I guess you would send this as soon as the user pastes their message, you would send this context window, and then it would speak this. And so the latency to first token, you would wait till it's done speaking this, and then if you started having tokens stream back in, then you could start speaking immediately.
Exactly. And
Okay, cool.
like this thing takes like a second, like 1 point. The cool thing about voice actually that I've noticed that I actually find to be an interesting plus is as a medium, most voice takes longer than you think. Sure, let me take a look. Is like a 4 to 5 second. Is like a 4-second utterance. So what you did is you almost bought yourself 4 seconds of time by default by having that sentence be spoken. Because you can say it slightly slower as an agent, like, sure, let me take a look for you. Or hold on a second, I'm looking up some stuff. Even small phrases like that have baked in latency. You don't even have to pass them in as context if you don't want to. It just makes it flow better and the vibes gets better if you do. But you've now addressed.
I have a quick question on this. So I'm assuming you're doing this in streaming mode. You're not essentially waiting for the LLM to complete everything and then show it back to the user. One of the hardest things I've found there, like I think the latency hiding part makes a lot of sense, but when you actually set up the streaming, you kind of have to define these stop words, or at what point should the LLM start to respond, right? So how do you set that up? I have always found that to be very challenging. Like, should it look for punctuations or some sort of words? Could you speak more about that if that's on the agenda?
Yeah, so could you repeat the question one more time, Abhimanyu?
Sure. So if you set this up in streaming mode, you kind of have the opportunity to define at what point should the chunking happen of the user's input. And there are multiple ways to do that chunking. How do you recommend we do that chunking?
You mean for the actual text that you're sending back to the user?
No.
Like,
for when the user is speaking, you could either wait till the end of the user's turn being over, or you could chunk it up and start sending it already. So what's your recommendation there?
I think it depends on what trade-off you want to make. If you don't care at all about money, honestly, what I would do is I would just send it like every single time you get like an utterance of some kind where the user's made some semantic statement, like kind of what Kyle was alluding to using those models, you just send it every single time. But
okay, so then if half a second later your turn detection model says, okay, now the user is done speaking, you gained half a second there because you already sent the last token out.
Exactly. So this is assuming you don't care at all about money. We're purely optimizing for latency, accuracy, and vibes. I didn't say cost in that equation at all, so I'm throwing that away. But the trick here is not to actually send the response back to the user at all times. Because anytime the LLM fires off, what ends up happening is the user starts talking, and let's just assume that this is the entire user block, and the user's speech pattern looks something like this. There's a little pause in the middle. And then we detected like somewhere around here. Somewhere around here is when we detected that, hey, the user ended semantically. And we also detected that it ended semantically over here. And then we also detected that they ended semantically around here. And they re-began their speech around here. And then we detected there was another semantic end over here. So what you would gain over here is you would have technically fired off an LM call. Oops. You would fire one LM call on here at this point. You'd fire another LM call over here at this point, fire a third one here, and a fourth one here. And then it becomes your job to think about which one of these is the most semantically relevant and which one of them are actually going to go ahead and do a good job. So for example, it's very
So when this one finishes, you would say, oh, but we detected they already started speaking again. So you would like basically end up throwing all three of these out. and then using this
using
one,
the
right?
bottom. Or
Yeah.
or what you could say is one thing that you'll notice is maybe all the user said at the very end was at the very end over here was something very simple like, okay, and everything in here didn't actually matter, it didn't contribute in any meaningful way. It just meant that it was just like a culmination thing. If you're able to quickly detect that the thing over here didn't semantically change anything or add new information, you can actually just use the first one.
So,
And the first one start
question over
responding.
here, like so this is the typical way of doing this, but what if we were able to just, so thinking about it as how humans speak, right? So can't we just have a system where the LLM so the user's talking, now the LLM has enough information or context to reply. So, I mean, we can just start the conversation there. So once you have enough information to give a response back to the user, and also have other
The
cues like
problem
emotion detection within the voice too,
The
right?
problem that you run into there, Sahil, is if you're a business and you're running this, like the most common use case for voice agents right now is like booking orders of some kind or like sales support agents or something. The thing is, all of those like sales and support are very, very cautious roles. You really don't want your support agent to be super aggressive with the customer. Like, and just like be like, oh, did you do this? Did you do this? Did you do this? That's a bad feeling. So you'd actually prefer to be more on the cautious side rather than the aggressive side of having speech happen. So while you're right, we could do a background test of going to go listen. We want to be as fast as possible, but at the same time, we want to make sure that we are not interrupting. We want to minimize interruptions from the agent side. We want the human to interrupt us, but we don't want the agent to be interrupting the human very often.
Okay. We're at 30 minutes, and I think we got a tight hour going today. So I'm gonna say let's pause on questions. Drop your questions in the chat. I'll keep an eye on them, and let's talk about the supervisor threading thing. And we'll have at least 10 minutes to look at the code, and then we'll have 10 minutes at the end for questions.
Exactly. So this kind of leads us into the next part, which is like when you're going to have a voice conversation flow, we are going to naturally go off track. So right in here in this optimistic LLM call thing that we saw that we could have started an LLM call. The user said something meaningless in the last 5 seconds. And therefore we have to go delay and then run another call. But if we ignore that, we technically could have all the data we need to respond with as early as possible, and we could respond much, much faster. We could use call 1 instead of call 2. Oops. We could use call 1 instead of call 2 because call 2 really added nothing beyond the okay. So we can ignore call 2. We lost some money. That's okay. We just abort the call. We stop spending money on that one. What's really interesting about this, in my opinion, is the key part depends on being able to detect that the part okay is actually a totally meaningless thing in terms of content creation. This is very, very, very similar to exactly how you want to do interrupts in long-running contexts or long-running conversation flows. What you want to do in a very, very long-running agent is you want to have your timeline, you want to have your agent talking, you want to have your human talking, and maybe there's some overlap, that's okay. Oops. Sorry, I don't have my mouse today, so I'm slightly uglier in my drawings, Dexter.
You got nothing to apologize
Agent,
for.
human, agent all the way through, and there'll be some exchanges over here. And conversations will happen. But we kind of want to have a separate, almost want to have a separate agent that's running in the background every single time the human says something or at some fixed cadence that is going to think for some longer period of time to smart agent or supervisor agent. We can call it whatever makes sense, Dexter.
I will call it the supervisor.
Okay.
Since that's what the code says.
Yeah. That's basically monitoring the task to help the main agent actually re-steer itself. And what we'll do is every time the supervisor detects that something is off, what it will do is regardless of what the human is saying, regardless of what the agent is saying, if the supervisor says something is off, we will take the previous conversation thread at the snapshot point that the that the supervisor agent was kicked off. So in this case, it's right after this agent call.
Can I make one change to this real quick? I think the supervisor agent is probably reviewing what the agent says, right? So it kind of starts here.
Yeah, sorry. And for the purpose of this, can we do it right? Can we do it right after the second call? I think it'll be more clear.
Okay, cool. That's fine.
So what we're going to do is we're going to delete what the human said. The supervisor agent is going to say something went wrong. So we're going to keep our conversation history, our context window built in with everything up in the conversation until this conversation point. Then we are going to inject a placeholder. Oops. At this point.
Something like, oh wait, actually, or like, sorry, 1 sec, or whatever it is.
I'm so sorry. I'm so sorry. I'm sorry. I think I may have gone off track.
Yeah.
Can you give me a few seconds to confirm?
And this is basically your supervisor agent, when it's done, is going to output like either on track or off track.
Exactly. And you can see how specifically what I've done here is the placeholder is actually pretty long. But it also immediately gives the user context on what happened, which is it thinks that we made a mistake of some kind. It thinks that we want to go off track. It thinks that we want to go recollect and collect some more information, and it's going to go do that. And once this happens, we're going to take the information, we're going to kick off another thread from a larger model of some kind, which is going to take the previous context. It's going to take the most recent human message on top of that. It's going to take all the stuff we need. I don't know how to build arrows. I can't do arrows on my current machine, Dexter, sorry. It's going to take all the things that were detected as need changes. It's going to take the most recent human message on top of that self. And then it's going to help, it's going to try and produce a response of some kind.
Yeah, so that would be something like, yeah, before I can book you, actually, I need to get your email before I can take any more details or whatever it is.
Exactly. And we still want to have the context of the most recent human message that came on, because that's what's going to make it feel so much more natural, in addition to, and then say, and we want the prompt over here to be something like, the conversation seems to be slightly off track, needs changes. Also, after that point, the user said green text.
Yeah. I'm curious because this is similar to the demo that I put together. But let me actually pop into the code and I'll show you the prompt that we give the agent.
That's actually probably even a better thing to help people see exactly what we mean, because we'll pseudocode this, but we have the real code, so we might as well show that off.
Yeah, let's just look at this, and then we'll pop back to the whiteboard and we can whiteboard out a little bit more, just so you have the exact details. So we have a small model, which is GPT OSS, running on Cerebras. The small model, the voice model, the thing powering that, the most important thing there is you want it to be really, really fast, right? You want it to be able to time to first token fast and just generate text quickly.
So because we don't do any of the latency tricks, we don't do any of that stuff. Instead, we just use Cerebras, which is probably one of the fastest time to first tokens out there, and we use a very small model, 120B. So we don't have to do latency hiding, because basically the only latency we have is network, and that's acceptable in almost every use case.
Yep. And then we have GPT-5 as our kind of slower, more thinky supervising model. And so the actual
functions,
the actual like code, oh yeah, let's go to the functions. So I actually didn't end up using this yet, so I'm gonna leave this commented out. But we have the small one. I had to name the assistant Tony, because when I was pasting in this was wild. When I was pasting in the thread, I was like, hey, this thread didn't connect right, and it said user assistant. The model actually went and like Claude Code started continuing the conversation. It saw user and assistant, and it was like, okay, so the supervisor and the model's name is Tony, so that it said Tony instead of assistant. But anyways, the point is say we say, okay, be conversation helpful. Here's the conversation so far, and respond as the assistant with your next message only. And the way this actually gets generated out is I'm going to turn the BAML logs on real
before we
quick.
actually go run this? Before you actually run this, do you want to run
Yeah.
Do you want to show me do you want to show the prompt?
Oh yeah, the supervisor agent prompt. So this is like you're an AI supervisor who picks up the phone of Tony, who picks up the phones. Here's the rules, right? Always get the user email address before confirming any booking. If like the answer must be that you have these vaccines, never provide legal advice. So this is all the things that the supervisor model is going to get the conversation. And so the prompt is, review the conversation below. So the user is like, here's the conversation, and then here's the instructions. And then we give it the output format. And so the prompt here looks like, sorry, go ahead.
And one thing I want to call out here is like we basically do our best not to spend a lot of time prompt engineering this. And the reason for that is like we just throw it at a bigger model. We just toss that GPT-5. It's okay if it runs slow. Who cares? Because like the main task is going to run real fast, so it's okay.
Yep. And then we say either respond with on track or needs adjustment with a message. And then here's the schema we're responding. So we have it when it decides you need adjustment, it actually includes the correction message right there. And it always has to start with like, oh, wait, actually.
Yep.
And so let's see. Yeah, we can run this one. So this was like, I want to board my cat. So like I said, hey, like I want to like, where is it? One of these like, oh, I need to board my cat. And the assistant says like, sure, I can help you board your cat. What dates are you looking for? And then the supervisor is supposed to say, actually, we only care for dogs. And so this gets injected into the context window as part of it. I can show you a little demo here. And I'm going to leave the BAML logs on. This is just text to text.
Another
you can
really
see
awesome debugging thing that Dexter did here is in his voice agent, he actually built a text mode because it is very hard to debug voice only agents. So like one nice caveat about having speech to text, text to voice is you can add the modes very easily by having those models in there. And you don't have to always use voice.
So this says it's on track because it actually did the smart thing and said we don't board cats here. But let me control C this. I'm going to turn the BAML logs off so you can see a little bit more detail. No, he's a great man. Okay.
You should tell
Gordo
it. You should say your boss. Yeah. There you go. Smaller model will eventually be dumb.
Okay, so here's the supervisor model. This one's actually a little bit buggy because it only checks for supervisor injections on the next assistant message because I built this in a hurry. But you can see it's coming through and saying, actually, we only board dogs here. And here's the message to say. So this code is a little bit janky, but if you want, we can try the voice mode and see what happens.
Let's do that, Dex. Let's just show that off really fast. And
All
then
right,
I want
let's
to
try
show
it
a
out.
little bit more about how the threading models work here.
And I haven't actually tested the speech to the text to speech side of this. We need to board my dog, Gordo. He's 45 pounds and he is he's actually not a dog, he's a cat. Okay. Anyways, this is we're gonna not mess with this too much.
Okay.
But now you have the format and the prompts. Is there any other code parts you want to check out?
Yeah, well, if we go back to the whiteboard, I want to talk about one or two more things really fast.
Yeah.
I think one or two of the things that I really want to talk about is a threading model that goes onto here when you go build this out. A really, really important part about this, and we touched on this again in the interrupt video, is really the threading of how often you run the supervisor agent. So the implementation that Dex was working on was an implementation that runs a supervisor agent on every agent message that comes across. You can do that. That basically is infinite cost. That scales with this. That is very hard to regulate and do things on. Another thing you can do is you can actually instead just run the supervisor agent once every 50 seconds, assuming that, or once every 5 seconds, or once every 10 seconds, assuming that a message has happened. The other thing you can do is you can optionally turn on and off the supervisor agent during critical parts of your pipeline. So if you have a pipeline that is, for example, during form collection, that might be an area where you want to turn on the supervisor because you really care about the form collection being perfect. And if the form selection ever goes wrong, it just doesn't work in any meaningful way. So
And you could have different supervisor agents, right? You could have one that's just checking for compliance and another one that is like, hey, make sure that there are no typos in the data collected and things like that. And make sure
Exactly.
the email looks like a real email and all that stuff.
So when you go do this, I think that's why the supervisor agent name somewhat kind of irks me. I was just like calling it like a validation agent of some kind. And like each validation agent has some specific kind of like thing that it validates for, and it might have multiple things it validates for at the same time. But in general, this is what I find works really well. Having like treating this like a multi-threaded process where you're choosing how many threads you want to run at parallel at any given time, on what messages you want to run threads on. You can do something more specific, which is like, hey, what I actually have is I have like a classifier that runs at the very top. And based on the classifier, I pass it on to different supervisors for every message that passes through along the way. So I actually have like, I have my like legal disclaimer. I have other things going on, and then I pass it in accordingly. And you can build this system. You can, instead of thinking of the system really as a supervisor, what I like to think of it as is I highly, highly recommend thinking of this as more like a workflow. Which all you're really building here is given the status of some conversation flow that is going on, I want you to analyze it and determine some way to define the state of this conversation.
Yeah, you're basically building out a state machine, and there's all these different transitions, whether it's like supervisor interrupting or like small model correcting itself or something else.
Yeah, sorry, just to be very, very specific on what I was saying is what I mean is once this agent human conversation is being built out, all a supervisor thread really is, I'm going to copy and paste this. It's basically an introspection into some flow of conversation that happened that's frozen in time. It has no updates given to it at any given point. And whether and just you're just looking at the status of this to be like, what is true about this conversation?
Okay, and then you can have that be like classify as one of three things. You can say create a summary. You can say
if it's
evaluate
on
which
track,
rules are, give me a list of rules
changes.
that are broken, whatever it is.
Exactly. And that's all a supervisor is. And now what you need to decide as an engineer is just how often you want to run this function that takes a conversation history and snaps it back. And then
And
Go ahead.
just to be extra clear, like in reality, the context window we send to our supervisor agent is actually like, hey, you're a supervisor, there's some text here. And then in one of your user messages, you say, here's the conversation so far.
Yeah, but it doesn't even have to be a full it doesn't even have to be a single agent. It could be like 7 different agents that all have different prompts, that all have different contexts. It doesn't even matter. For some agents, you might only want to give them the last 2 seconds of context. For another agent, you might want to give it the whole context over the lifetime of the user. And that's a thing you might want to run like once every minute because it takes forever to run. There's so many different ways to go define this that I would say that I wouldn't really I wouldn't even pin the name supervisor to it because that implies that's a single function that's running. I would view this as a very complex pipeline that you will build over time. And I think a lot of people say evals are their secret sauce. I think for voice agents, this part of your pipeline is your secret sauce. This is the secret sauce for every single voice agent. How well can you steer the conversation on the fly? And then, depending on how you represent state at this time, so like Dexter has a thing that represents one type of state, is like on track versus needs changes. And then there's like a string attached to this possibly of like what changes it needs. That's one type of status that we have. You could have tons of other statuses like what is this user doing? What is going on in this conversation at any given time? And then you as an engineering team could actually build a real-time dashboard that actually shows you the flow of a conversation over time. So what I really would want to see if I was building this type of voice agent is not a lot of people build like DX on like what is a voice agent along the way. They say the conversation. None of that matters. What I really want to see is I want to see snapshots of in Dex's case, what I would love to see, snapshots of the supervisor agent showing me the conversation and literally showing me the points in time when it went from green. How do I fill this in? Green to red, where it went off track. And I just want to see a timeline of how often this happens. And the KPI that I would be tracking is how much of the time is a supervisor agent spending on time versus off time, off task. And that is the KPI that I should be tracking for my voice agents. And if I can do
So
this,
you're sending this chunk, and then you're sending this chunk, and then you're sending this chunk, and basically just like whenever it gets back on track. And that's your eval, that's your KPI of like how good is this agent at least at following the rules, right? That making the experience for the user good is like that's our like optimization as far as like how do we build a good product. But our KPI is like we need to make the experience for the user as good as possible without like giving people medical advice when we shouldn't be.
exactly. And then I might want to have metrics on like what kind of things does it go off track on? Does it go off track on legal issues by giving legal advice? And that's why my supervisor agent triggers. And once I can figure out what stuff is triggering, then I can go ahead and like minimize some of those and say, okay, I definitely don't want the main agent to going on legal stuff. So let me go modify my main agent's prompts to go emphasize that it shouldn't go on legal tangents because it seems to be doing that a lot. It definitely shouldn't be directly scheduling because it didn't call the tool call correctly. Well, in that scenario, great, let me go fix that problem and actually make sure that instead of scheduling this tool, anytime scheduling gets called, anytime the main agent tries to schedule anything, I have a really lightweight supervisor agent, perhaps another 120B model that's running, or even a 20B model that's running to see is it scheduling without calling a scheduling tool call? And if
Right.
it
Instead of
is,
having all of those, like, here's 10 rules, tell me yes or no, it's like, cool, classify each of those rules in a separate parallel call to a really small LLM of just like, is the model giving medical advice? Is the model XYZ? Is it okay?
exactly. But I don't want to go do that on day one because then it's going to make my system very heavyweight. So I'm gonna slowly incrementally build that up from day zero. And I would do exactly what Dexter did, which is have one scheduler agent in the beginning. And that's one supervisor agent that has a bunch of giant prompts. That I'm gonna have one giant scheduler supervisor agent with a giant prompt. And then I want to build a dashboard for my team to look at every conversation in a timeline view with colors, just to know how off track and how on track it went. And then the minute that happens, I want to go ahead and just go and optimize accordingly based on real data of real conversations. Because there's no prompt optimizations you can do by just listening to the whole conversation. If any of you have ever looked at post-hog like screen recordings for your website or any other system, the most useful part in those screen recordings is actually not the screen recording. It's the part where they skip the 8 hours of inactivity. Like you need to go and find the events in your voice agent to go build them out. The rest of the actual stuff of like writing this code out is like super, super easy. The actual code is like, we all know how to write a function. Can you scroll up, Dexter?
Yep.
We all know how to write a function that says where one of the inputs is a conversation of some kind, and I want to go figure out what, like, describe this conversation status to me. That's a data extraction problem. You write a class model that says, I want to know the shape of this data in terms of how on track is it? Does it give legal advice? Does it do X, Y, Z? And that's just an LM prompt. We can go do that. We might want to use like, maybe with some old classical techniques. Maybe we use like keywords to be like, hey, is the model shouting obscenities just by looking at it? And any of this.
That's what we do it in old like automated phone trees, right? If the user is
Exactly.
swearing, we immediately divert you to a human.
Exactly. So you can do all sorts of things like this along the way. But that stuff is just standard code. You don't have to learn anything new. The key part to a voice agent is the threading model that you need to think about and just spin it off in a background thread and build an interrupt workflow that takes the learnings from this state and somehow resets the context window with something like, I'm sorry, I have to go off track, and generates a new message. so that you can go back on track to what the user might want. And two, learn how to build evals for voice agents, which is really, can you scroll down? Which is really more about understanding the high level flow of a conversation. And sadly, there's no shortcut there. You just have to go build out like a colorized view of your timeline almost. And most people don't actually build the colors. Most people have no idea how often they go off track. They use, and vibes are really, really good when you're listening to one or two conversations. But like if you're lucky enough to actually have like over 100, 200 real customer conversations, just plot it. And the minute you have over 100, 200, plotting is going to do way better work for you than anything else can.
Yep. A lot of comments, not a lot of questions here. Can we use a similar supervisor to compact the context so when the conversation goes really, really long, we don't need to pass in all the messages? Great question.
Yes, the answer is yes, you can. And you definitely should be doing that. But you can think of it like a form filling question. If you've ever done that, have you ever written a form filling agent, Abhimanyu?
Yeah, sure.
Yeah. So it's the same thing. Once you have a form filling agent, you're kind of, instead of even having the whole conversation, you can just replace a lot of the previous messages with just the current form is this. What is the next form? And that's kind of like compaction in some sense. Kind of almost a better compaction than anything you could have.
Right.
Yeah, go ahead.
No, I was just saying, like, in cases where it's very clear what that artifact is that you're trying to get out of the conversation, it's very simple. That's the artifact that gets preserved throughout the conversation and nothing else.
Yeah. The harder part is when you have a more ambiguous artifact. What I recommend in those scenarios is see if you can have the user guided through some checkpoints. I think the mistake that people make with voice agents is the same, is very similar to what they do with chat bots. If you have a chat
bot, it's just one prompt for the whole conversation instead of having like phased, like different LLM based prompts for different like parts of the conversation and checkpoints.
Exactly. So as long as you can have some sort of checkpoints in your conversation of some kind, then you can always have some like save point that you can always revert back to if something goes horribly wrong. And I find that to be very, very useful for any.
So this would take you to like a structured output.
Yeah.
And often then this becomes part of the input to the second agent, which has like a new prompt.
Yeah. And often, I wouldn't say every tool call is a good point for a structured output or like a checkpoint, but some specific tool calls are great checkpoints. So for example, like if you're booking an appointment, collecting information, doing all that stuff is not a great checkpoint. But the minute you've booked an appointment, or like the minute you're gonna confirm with the user whether or not they want to book an appointment, that is a great checkpoint. So like you could naturally think about this based on the flow of your conversation of what you would do here, and then build that out. The second part that I would think about when you go do this is actually about UX. I think sometimes people expect their users to have no tolerance for anything. But honestly, if I've been on the call for like 5 minutes with an agent for a long time, and 5 minutes isn't that long, but even at 5 or 10 minutes, and then you as an agent told me, hey, this conversation is actually getting quite long. We're going to use a slightly bigger model, so you may have slightly slower response times from now on. I think I would forgive you as a software and not be upset at you at doing that. But if you didn't tell me that and you suddenly started taking a lot longer, I'd be very annoyed. So I think having transparency with your users is a great way to solve that problem as well, if you don't want to compact the window.
Cool. Other questions? Amazing. Y'all, this was super fun. We'll get this posted. Thank you, Vaibhav, for calling in from Berlin. I know it's late there. Appreciate all of you all. The code is already live. We're going to clean up the GitHub repo. We'll get the video and stuff pushed out by ideally, I think, probably sometime tomorrow.
Yes. It might not be tomorrow, but it might be the day after, but it will be live soon. Germany time, but I guess maybe tomorrow, PST time. And then we'll probably get another sample set of some of the more fun stuff with actual interrupting and everything when I'm back in the States, and we do another episode on it. And hopefully we'll have more threading code available then as well.
Yeah. Sounds great. All right, dude. Thank you. Thanks, everybody. See y'all next week.
Adios, everyone.
See ya.